Well, let's take a look at hyperbolas and see how. I'm guessing that we're going to have to take two videos to finish this one up, but we're going to do our best. So let's take a look first at the shape. If I have a hyperbola that looks like this, it has two branches to it, and let's do some names here. We're going to call this the transverse axis. Transverse axis, also known as the focal axis. From my understanding, the transverse axis just goes from the vertice to the vertice. The focal axis is the entire axis. The one that is perpendicular, the perpendicular axis is called the conjugate axis. The distance from our center to our vertice is still our A. The distance from the center to the focus is still our C. And the B in this case is going to be the distance up. That's B, and the distance down. And so what we end up making here through the vertices and the distance B going up and down, hitting the vertice, you get this square. And if you hit the vertices of the square and the center, you get these asymptotes that your hyperbola goes out to like that. So that's what we're going to be playing with here a little bit. Let's see if we can do a little bit of assigning some variables to stuff. Again, we have one going this way, one going that way. There's our center, that's a vertice, that's a vertice. We have a foci there, we have a foci there. So this would be the transverse axis. This would be my conjugate axis. And, you know, if you want to call it the focal axis instead of the transverse axis, again, my understanding is the transverse is only from vertice to vertice, and the focal is the entire line. But I'm going to probably use those interchangeable. Just understand what's going on there a little bit. A before B, in this case, we're just the A. You'll understand the A and B from what I just said. The equation form that we're talking about here is A minus, and our A or our B can be bigger in this case. The A doesn't necessarily have to be the larger one. In this case, we have branches right and left. Our foci are going to be at C and negative C. I think we kind of covered that. Our focal axis is going to be, well, in this, because the vertice or the center is at the origin, we're going to be at y equals 0. Our transverse axis is going to be 2a, our conjugate axis is 2b. And our asymptotes, the asymptotes that I talked about making the box, is going to be plus or minus b over ax. And we can change that if we're not at the origin by just saying y minus k equals plus or minus x minus h. So we just move it off that origin by plugging it into that. Our relationship between a, b, and c here are a squared plus b squared equals c squared. Let's take a look at what happens when we do the other orientation, where it's opening up and down. Everything stays the same. We still have the A is under the Y in this case. No, not saying that that's always the bigger number. I'm just saying that that's the A because this is the distance A to the vertice. Whatever that is, that's your A. So our branches are up, down in this case, and our foci are still at the distance C and on that axis. The equation of my focal axis is going to be the y-axis, which is x equals 0. Our vertices are going to be at plus or minus a distance. Transverse and conjugate axis is the same as before. And our asymptotes in this case, because of the other orientation, is the a over b slope. And again, same as the last one if we want to move that off the origin. Okay, eccentricity, same as it's been for the others. We're going to notice that our eccentricities for hyperbolas are always going to be greater than 1. All of our ellipses that we talked about, all the eccentricities were less than 1. So let's start with playing with this one. We're going to get it in standard form by dividing everything by 400. And so I get the equation x squared over 25 minus y squared over 16 equals 1. We know that, if I'm going to draw a cute picture of it here, because the x squared is first, it's going to follow the x-axis. So it's going to look something like that, give or take a half mile. And we're going to find all the stuff for it. When we get done, my graph might not be accurate, but we'll see what it is. We still know that our transverse axis is there, our conjugate axis, our focal, if you want to call it the focal axis, we can do that there. We're going to start naming off all the stuff that we know. Let's start at the center. Is at 0, 0. Our vertices are going to be the distance of A, so that since this is the distance A, our vertices are going to be at 5, 0, and negative 5, 0. We know our foci are going to be at distance C, so let's do an A squared plus B squared. Let's see, we get 25 plus 16 equals C squared. Looks like I'm going to get the square root of 41. So my foci end up being at square root of 41, 0, negative square root of 41, 0. And my transverse axis, which is, again, the distance from there, my trans-axis is going to be a length of 10, because from negative 5 to 5 is a distance of 10. My conjugate axis, which is important because we're going to make that box to find the asymptotes, is going to be a distance of 8 because of the 16 over here. That's distance B. And our eccentricity here is our C over A. Last thing that we need to find is our asymptotes. And we know our asymptotes when it's this orientation is going to be the plus or minus B over A. So I'm going to say plus or minus 4 x. So if I was to make my box here, I'm going to, my B would be 1, 2, 3, 4, 1, 2, 3, 4, 5. And so then my asymptotes would look like this, and my graph would look a little wider than I drew it. But you get the idea. All right. Let's take a look at this example. This example I put on here to kind of show you what happens when we don't have, when the normal form is that equals 1, but usually we have denominators instead of numbers in front, and how are we going to deal with that? So I put this one on here because I can rewrite it as y squared divided by a half minus x squared divided by a third equals 1, just rewriting it so they're by itself. And we can find, we know that my a squared is equal to a half, so a is going to be the square root of 2 over 2, rationalizing that. We also know that my b squared is going to be equal to 1/3, so b is equal to the square root of 3 over 3. And then I can find my c by saying, hey, a squared plus b squared equals c squared, and so I'm going to get 5/6 equals c squared square root, which gives me the square root of 30 over 6 when I rationalize that guy. So it looks like I have enough information to answer most of the questions here, so let's get to answering questions. We know our center of this thing is at 0, 0 again. Most of them have been so far. We're going to have to do one without that. I have a vertice. Well, let's look at the orientation of this one. If I have the y squared first, it's major axis, it's conjugate axis. No, it's transverse axis is going to be the vertical axis parallel to the y-axis. And the distance to those guys are going to be the square root of 2. So I'm going to go with my vertices being at 0 square root of 2 over 2 and 0 negative square root of 2 over 2. My foci, and again, those are the distance c, and I think we already have that, so I'm going to use square root of 30 over 6 and negative square root of 30 over 6. My transverse axis is going to be 2 times the square root of 2 over 2, or just the square root of 2. And my conjugate axis is going to be 2 times the square root of 3 over 3, twice that. And my eccentricity is going to be the square root of 30 over 6 divided by the square root of 2 over 2. Doing a little bit of that cool math stuff that we do, I'm going to come up with the square root of 15 over 3. Then, to get the last thing it's talking about is the asymptotes here. And I need to, my asymptotes in this case are going to be the plus or minus a over b. So I'm going to go square root of 2 over 2 divided by the square root of 3 over 3x. And if I do a little bit of simplifying there, I get plus or minus square root of 6 over 2x. All right. Main reason for this one is how do we deal with these numbers here when we don't have numbers in the denominator, which all the other problems are going to have the numbers in the denominator instead of the numbers greater and putting one up there. All right, so let's see if we can, there we go, actually see it. Determine the center, vertices, foci, lengths of the transverse and conjugate eccentricity, equations of asymptotes, and try to make a pretty graph. Let's see if we can do all of that. Oh boy, I'm going to have to move that down there. All right. We'll get to that when we get to that one. All right. I'm going to see if I can get done with this one before the end of the time and then start one, finish up on a second video so don't get freaked out. So this one, since it's already in the nice form, I'm going to start with center is at -1, 2. My vertices are going to be distant 2 from that. So if I make kind of my picture of this, I have a -1, 2. There's my center. And, oh, I'm not even going to finish this. Well, I'm going to start the next video and do the rest of this one. So we're going to shut this down.